Welcome to lesson 18, problem number 1, where we are beginning the process of factoring. So when you factor polynomials, finding the GCF, or the greatest common factor, and factoring it out is always going to be your first step in factoring. So let's look, just to remind you of what a greatest common factor is. The GCF between 3 and 12 is 3, because it's the largest number that goes in evenly to both 3 and 12. And so then we figure out what we need to have still in the parentheses, because if we were to distribute that 3, we should get back to the original expression of 3x minus 12. Some people like to do it by saying, oh, I'm going to divide the 3x by 3 and get x, and divide the negative 12 by 3 and get negative 4. Whatever method works for you, but the bottom line is you have to have that greatest common factor on the outside, and in the parentheses is what exactly you would need so that if you were to distribute it back through, you'd be back at 3x minus 12. So that was a long explanation for 1a, but now we are going to roll through the other problems using the same concept. So b, we're going to take out a negative 7. By the way, when the leading coefficient is negative, to take out the greatest common factor, you should always factor out the negative version of the GCF. So in this case, we have s, and be a little careful, that's an s, not a 5. And then we have minus 5, because negative 7 times negative 5 gives us positive 35. Okay, beginning with C, we have variables. The greatest common factor for variables is the variable to the highest degree that we can take it out to, but it has to be common to every term. So in this case, we know the GCF for the number is 9. And then we can also take out an x to the first, because there's an x squared here and an x to the first here. So the largest power of x that we can take out is to the first, because it's the only power that is common to both 9x squared and 27x. If we tried to take out 9x squared, we would end up not having a way to factor it to get back to 27x, unless, of course, we use negative exponents. So it's 9x on the outside, and on the inside, it's simply x plus 3. And there's plenty of practice on this particular concept, so I'm going to kind of roll through a lot of them without worrying so much about explaining every little step, because if you have questions, you know to email me. Okay, the next one, 5 is the GCF as far as the number, and you cannot take an x out this time because there's no x in that last term. So it's simply 5 times 3x squared minus x plus 4, and you're done. Okay, the next one, between 17 and 34, you can take a 17 out, x squared and x to the 7th. So you could take out an x squared, y to the 4th, and y to the 5th. You can take out a y to the 4th. Okay, this one's a little bit tricky, because when you get the parentheses, I'm going to change the color. The only thing you need to make sure is that you don't just skip that first position. We need a 1 right there so that we could indicate that if you were to distribute, you'd get back to this to the first term, 17x squared y to the 4th. So you need that 1 right there. Then you need a plus 2, and that would give you the 34, x to the 5th y. Try multiplying that through to show you why that is exactly what you need in the parentheses. So 1 plus 2x to the 5th y, and the 17x squared times y to the 4th, 17x squared y to the 4th is on the outside. Okay, let's look at the next one. We're going to take a 9 to the outside. This time we can take out an x. So a 9x, and inside we have x squared minus 3x minus 2, and we're done. Okay, the next one, we can take out an a to the 2nd. That's the highest degree that occurs in both terms. We could take out a b to the 1st. Highest degree is 1 that occurs in both terms for the b. And then we could take out a c to the 3rd. In parentheses, we don't need an a for that first term, but we do need a b squared, c squared, and then we have a minus sign, and then we have an a to the 7th, and then we have, that's it, just a to the 7th. We're done. Okay, H. This is a fun one, because 11 is our greatest common factor as far as the number part goes, and then the k can be taken out all the way up to the 3rd power. Notice this one is not in descending order or standard form, but we can still factor it. So we took out an 11, k to the 3rd, which means we need an 8k in that first position. And then we need a minus k to the third, and then we need simply a minus 4, and we're done. Okay, the next one. The GCF between all of those terms is simply 4. So it's 4. I'm going to actually take out a negative 4, though. You don't have to. You could just take out a positive 4 if you wanted to. But normally, the protocol is that if you have this in the highest degree term is first, that makes that leading coefficient the negative 40. Since it's a negative, we'll pull out the negative 4. Okay, we can take out an a to the first and a b to the first. So negative 4ab, and then we're going to have 10. That'll give us the negative 40 ab squared. Then we have minus 2, and then we have a plus 5c. Done. Next one, we're going to take out the, this one is not in descending order. We don't have to put it in descending order, but let's just take out, to begin with, the negative 4 is our highest degree. I'd still like taking out the negative, if possible, for the first term in whatever order it's given. So we have negative 4, we have an a to the first, and we have a b to the third. So a to the first, b to the third. So our first number in the parentheses is going to be a 2. Oh, I take that back. There is no a. I misread that. I need my reading glasses. Okay, let's redo that. There's no a in the first term. So all we can take out, sorry about that, is going to be a negative 4 b to the third. Okay, so in parentheses then, we're going to have a 2. Then we're going to have a minus 4, which will give us a positive 16, ab to the fourth. And then we're going to have a plus 1, but we don't really need that 1. Let's just kind of leave it as plus. Let's make that look a little bit more like a plus sign. We technically only need the a to the third. We could say 1a to the third, but a to the third is a little bit simpler. We're done. Okay, this one is a light bulb, but the GCF here is the quantity x minus 9. Yes, a binomial can be the GCF. So if we take out that x minus 9, we're left with x squared plus 3x. And again, this is a light bulb, so I'm not going into a big explanation, plus 7. That's it. Okay, the next one, the GCF looks like, you'd wish it could be x minus 5, but this is 5 minus x. Now, because it's a light bulb, I'm going to show you something kind of interesting. I'm going to rewrite the left-hand portion of the expression, and I'm going to make that a plus y so that I can change that second parentheses to x minus 5. Notice if you were to distribute, this is exactly, I'm going to circle the two things in green that are exactly the same. This and this are exactly the same expressions. Multiply it out if you want, and you will see they are exactly the same. Okay, so now we have a GCF of x minus 5. And so left in the parentheses is simply 7 plus y. And we're done. Great job, especially on those light bulbs. Everything, though, was really challenging, and I went through it pretty quickly. Great job.